warahmatullahi wabarakatuh. My name is SITI binti SHAFIE, and today I will present the introduction and how leaf works, and a little bit about the characteristic of decision for our group project. Okay, for the introduction, as we know, the decision as speed regulator. So, easy reversing control, speed regulation, and low starting torque are all features of this motor. In this motor, the field winding can be connected in parallel with the armature winding. So both winding of the motors are exposed to the same power voltage because they are connected in parallel. And the motor maintains a constant speed under any load. The starting torque of the motor is minimal and it runs at a constant pace. So, how leaf works? An elevator's function is to convert the initial electrical power which runs the motor into mechanical power. In the elevator, there is gear to decrease the rotational speed of the traction pulley. By decreasing the rotation speed with the use of a gear reducer, we are also increasing the output torque. Therefore, having the elevator to lift larger objects for a given pulley diameter. But why we use DC motor in lift? Because we want high-speed elevators. However, so we use the DC motors. This is because DC motors usually have high starting torque than AC motors and ease of speed control. The rotating speed of the induction motor is rather constant. The DC supply voltage from the generator is variable, so by changing its field current, the adjustable supply voltage is applied to the DC motor of the drive. A higher voltage results in faster rotation and vice versa. With a high starting torque, this type of drive is appropriate for high-speed elevator application. Thank you.
My name is FARAHEEN binti MUSTAFA. My metric number is A1740887. So today I'm doing the simulation for our group. So basically our group have two simulations. First simulation is about decision motor characteristic. Here you can see at this on my screen is the circuit of decision motor decision motor. I'm using XY graph block to show the each of the graph manually, so it's easier for me to explain. First, I'm going to run for the first graph, which is armature current versus speed graph. So as you can see here, when the armature current is increasing, the speed in radian per second is decreasing. Hence, this is the first characteristic of decision motor. The second graph is armature current versus torque graph. As we can look at the graph, when the armature current is increasing, the torque also increasing. Hence, it is proof that torque is directly proportional with armature current. So next is the last graph, torque versus speed graph. So from the torque versus speed graph, we could see that when the torque is increasing, the speed of the rotor in radian per second decreasing. So I'm done doing the simulation for the first circuit, which is decision motor characteristic. Next, I will explain about our second simulation which is DC speed controller, the basic principle how decision motor control the speed of each load. So there will be two parts for this simulation. So first simulation I'm showing here is armature voltage control of decision machine. This is the armature voltage control decision machine circuit. I'm using DC machine, and the voltage, the DC voltage source will be 240 volts, and it is constant. The variable that I will change throughout the simulation is resistance. First, we will try for 1 ohm and run the circuit. As we can look here, the armature voltage at the armature voltage display here, the armature voltage when the resistance is 1 is 239.4 volts, and the speed in rad per second is 132.8. So below the speed in radian per second is speed in RPM, where I convert is using gain, which is 30 over pi to convert radian per second to RPM. Okay, next we will be using the 50 ohms. So as we can look here, the armature voltage decreasing, which from 239 to 102.8 volts, and the speed is decreasing, become 56.19 radian per second. So next we will try 100 ohm voltage, 100 ohm resistance. So as we can look here, the armature voltage is decreasing, as well as the speed in radian per second also decreasing. So we can conclude that when resistance is increasing, the armature voltage is decreasing, hence the speed also decreasing. So last simulation, part B of the second simulation is field current control of decision machine. So if I want to do the field current control, I need to change a little bit of my circuit, because I will be using the current measurement. And also the position of the resistance would be at field part. And I'm using current measurement block. So the scope I will change to field current. So let us run the simulation. Here we can see that the field current is 0.9959 and the speed is 133.7 radian per second. So when the resistance is 50 ohm, the field current will be 0.8276 and the speed will be 160.8. And last but not least is the resistance became 100 ohm. So the field current will be 0.7059 ampere and the speed in radian per second is 188.5. So in conclusion, we could say that when the resistance is increasing, the field current is decreasing, but the speed of the rotor will be increasing. So from this simulation, we can see that the basic working principle of this decision machine in controlling the speed of its load. The relation between decision motor in lift had been explained with my friend Aisha before in the introduction. So this is for the simulation, and thank you for watching.
Okay, based on this project, we have learned about a few of the characteristics of DC motors. So, one of the important characteristics of DC motor is that the speed of DC motor can be controlled by varying the voltage. As an elevator car can approaches its destination, it slows down as opposed to continuing full speed until the floor of the car is even with the building floor, then stopping abruptly. This would be uncomfortable for passengers and hard on the machinery. So in conclusion, we know about the DC shunt motor and how it works. So for the armature voltage, when the resistance increases, the armature voltage decreases and the speed will decreases. And also for the field current, when the resistance increases, the field current decreases, so the speed is also increases. Other than that, we learn about the degree of compounding. A DC cumulative compound motor can have a high starting torque of up to 450%. The speed limit varies between 25 and 30%. However, the DC shunt motor is not quite suitable for elevators because the starting torque is not quite high as the DC cumulative compound motor. So that's all for my group. That's all. Thank you.